Hello, good day everyone. So we're now in the fifth lesson of our fourth quarter. So we still have theorems on triangle inequalities wherein it is all about the Hinge theorem and its converse part 1. Okay? So our lesson objectives for this day are the following. Identify the opposite angles of the given sides and vice versa. Analyze the Hinge theorem and its converse and solve problems using Hinge theorem. Okay, so let's focus on the first objective, identify the opposite angles of the given sides and vice versa. Okay, so you are going to identify the opposite angles of the given sides and vice versa here. I have here the question, what angle is opposite to side CE? That's correct, we have angle D. Next, what side is opposite to angle ACB? That's correct. We have side AB. Next, what side is opposite to angle B? Correct. We have side AC. And what angle is opposite to side DE? That's correct. We have angle DCE. Okay. So question. Okay. So that's great. So let's now proceed to our next objective. Analyze the Hinge theorem. So I have here two sticks with the same lengths. Okay? So we are going to form a triangle using these two sticks, two different sticks, sets of sticks, using a protractor. So the first one will be with 90 degrees and the second one will be with 45 degrees. So for us to make sure of our angle, so we are going to use a protractor. Okay, so let's have the first stick. Okay, the first set of sticks. So we have here now a 90-degree angle. And then we are going to form a triangle. So let us just have the dashed line for the third side of the triangle. Okay, so there we have it, the first triangle. So let's now move with the second one. Let's make a triangle out of these sticks. Okay, so as you have seen, we have here 45 degrees. Then use the imaginary or the dashed line for the third side of the triangle. Okay, so we now have two sets of, or one set of triangles, or two triangles here. Okay, so how are we going to observe these two triangles? So what can you say about the opposite sides of the included angles of the two triangles? Again, what can you say or about the opposite side? So this dashed line or blue lines here. Okay, so what can you say about this since they are the opposite side of the included angle of the two triangles? So our included angle is this one, okay, and this one. What can you say? Yes, they are of the same length. Okay. So we have now the Hinge theorem or the SAS inequality theorem. So it is said that if two sides of one triangle are congruent to two sides of another triangle, but the included angle of the first triangle is greater than the included angle of the second, then the third side of the first triangle is longer than the third side of the second. Okay? So, just like what we have on our triangle inequality theorem 1. Okay? Wherein opposite, the larger angle or the largest angle is the longest side. And opposite the smallest angle is the shortest side. But this time, we are comparing two triangles. Okay? So before, we only have one triangle. Okay? Inequality in one triangle. So Hinge theorem is a triangle inequality with two triangles. Okay? So as you have seen, so a smaller angle is opposite the smaller side and larger angle is opposite the larger side. Okay? So let's now have another example. If the measure of angle A, this one, is greater than the measure of angle X, so this one in blue, then segment BC or side BC, this one, is greater than side YZ. Because, again, angle A is greater than, okay? So, angle A is greater than angle X. So, that's why side BC is longer than or greater than side YZ. Is it clear? Okay. So, let's have these examples. What inequality relates segment LM and segment OQ? Okay. So, for you to answer this, you are going to look for the opposite angle of the given side. So, here is our LN. The opposite side or angle is 125 degrees. Here is our OQ, and the opposite side is, or opposite angle rather, is 78 degrees. So, therefore, how are you going to relate these two segments? That's correct. We have segment LN is greater than segment OQ because the opposite angle is of segment LN is greater than the opposite angle of the segment OQ. Okay? Question? Next. How about this one? Segment AC is blank with segment RT. Okay? So we have here segment AC. Then we have here segment RT. Okay? So if you are going to, okay, to compare, okay, so we have, okay, so as you have seen, we have here, segment AC is greater than or less than. That's correct. We have less than segment RT. Okay, so it is less than. Next. Let's have this one. Based on the diagram below, which car is farther away from the mall? So we have here car A. We have here car B. So which do you think is farther than the mall? Okay, that's correct. We have car B because the opposite angle here is 100 degrees and the opposite angle here in car A is only 90 degrees. So that's why we have car B is farther because it has the greater or the larger angle. Okay, so let's have a situation here. Mina and Rita are both flying kites in a field near their houses. Both are using strings that are 10 meters long. Mina's kite string is at an angle of 75 degrees with the ground. Rita's kite string is at an angle of 65 degrees with the ground. If they are both standing at the same elevation, which kite is higher in the air? Which do you think? That's correct. We have Mina's kite. So as you have seen or given in the problem, it is 75 degrees with the ground, while Rita's kite is only 65 degrees with the ground. So that's why Mina's kite is higher in the air. Okay, next. Doctors use a straight leg raising test to determine the amount of pain felt in a person's back. The patient lies flat on the examining table, and the doctor raises each leg until the patient experiences pain in the back area. Nathan can tolerate the doctor raising his right leg 35 degrees and his left leg 65 degrees from the table. Which leg can Nathan raise higher above the table? So is it the left leg or the right leg? Which do you think? That's correct. So obviously, so we have the left leg. So we have your left leg is 65 degrees from the table, while his right leg is only 35 degrees. So that's why we have the left leg. Okay, question? Okay, so let's now proceed with the converse of Hinge theorem or the SSS inequality theorem in two triangles. Okay, so if two sides of one triangle are congruent to two sides of another triangle, but the third side of the first triangle is longer than the third side of the second, then the included angle of the first triangle is larger than the included angle of the second. So just like what we have earlier, smaller side is opposite the smaller angle and larger side is opposite the larger angle. Okay, so as you have seen on our example here, if you are going to bend the rubber band, okay, so opposite the larger angle is the longer side. Okay, and if you are going to unbend the rubber band, so you have the smaller side or the shorter side and the smaller angle opposite them. Okay, so let's have here another example. If BC is greater than YZ, okay, so again we have here if BC is greater than YZ, so therefore or then, the measure of angle A is greater than the measure of angle X. So we have just the reverse or the converse of our statement earlier. Okay? So another example of Hinge theorem is this one. The door openings. Okay? So if you have just a small opening length, so you just have a smaller angle. But if you open the door widely, so you have the large opening length, therefore, the opposite angle to that is a larger angle. Okay, question? Okay, so let's have here some examples. We have angle ABC compared to angle DEF. What do you think is their relation? Okay, that's correct. We have greater than because, as you have seen, opposite angle ABC is 7 inches and opposite angle DEF is only 6 inches. So that's why angle ABC is greater than angle DEF. How about this one? We have angle DEF, so this angle. And angle ACB, so this angle. Okay? So what do you think? Yes, we have angle DEF is less than angle ACB. That's correct. How about this one? Angle CAB, if you are going to compare with angle FDE. Okay, this is greater than. Okay, because we have the opposite angle or the opposite side is 10 and the opposite side of this angle, the second angle is only 8. Next, let's have this figure. Angle 2 compared to angle 1. Okay, so we have less than. That's correct because this is only 33 and this is 34 with angle 1. Next, let's have now the third objective. So we have to solve problems using Hinge theorem. Okay? So you are going to complete with greater than, less than, or equal. Okay? This relation symbol. Okay? So using the figure, the accompanying figure, let us have segment AB compared to segment DE. Again, segment AB compared to segment DE. It is? Yes, so we have less than because you only have here 105 compared to 110. Next, number 2, we have segment FG compared to segment LM. That's correct. They are equal. Okay, next, number 3, we have segment MS. So we have this one. And segment LS. So we have, correct, we have less than because opposite this is only 95 and opposite this is 98. Okay, so that's why less than. Next, number 4, angle 1 compared to angle 2. Again, angle 1, this one, and angle 2 is correct, less than. So it is only 7 and it is 8. So less than. Next, this one. We have angle 1 compared to angle 2. So as you have seen in the illustration, in the accompanying figure, they are, okay, equal. Correct. Next, let's have this one. Again, compare angle 1 with angle 2. Angle 1 is, okay, greater than the measure of angle 2. Because angle 1, opposite it is 8. And angle 2, opposite that is only 7. Next. So answer the question that follows. Is it Niva or Sean? So from the given situation, Niva and Sean both have their lockers open as shown in the diagram. So we have here on the first one locker, we have Niva, and on the second figure, on the second locker, we have the Sean, for Sean. So whose locker forms a larger angle? Is it Niva or Sean? Okay, so obviously it is for, okay, so the locker of Sean, because as you have seen, the opening length is 17 inches for Sean, while Niva is only 12 inches. Okay, let's have number 8. Is it plane 1 or plane 2? So the question is, which plane is closer the airport? So mas malapit. Okay, so is it plane 1 or plane 2? So plane 1 and plane 2. So it is correct. We have plane, okay, plane 2, because opposite it is only 48 degrees. So that's why we have plane 2. While plane 1 is 113 degrees, so it is farther in the airport. Okay, so let's have number 9. Is it Dave or Ellen? Which rider is farther from the park? Which do you think? So we have, okay, so we have Ellen. Why? Because the opposite angle of it is 90 degrees, while the opposite angle of Dave is only 60 degrees. Why? Because the exterior angle is 120. Therefore, this interior angle is 60 degrees because they are linear pairs. So that's why Ellen is farther from the point. Next, for the last question, let's have MN or RS. So in the diagram, a crane is shown lifting an object to two different heights. The length of the crane's arm is fixed. Which crane is shorter? So again, is it MN or RS? That's correct. We have RS because it only bends with 29 degrees while MN is 52 degrees. So that's why the shorter crane is RS. Okay? So that's all about the theorems on inequalities, on triangle inequalities regarding the Hinge theorem and its converse. So if you have questions, so just PM me. So that's all for this day. Goodbye.